Hey, welcome back to another episode of 5 Minute Computer Science. My name is Mr. K, and today I want to talk to you about dynamic data structures. There's lots of them out there, but the one we're going to be looking at is the linked list. You need to understand, how do you identify a linked list? How do you add additional items to the end of a linked list? What do you do to shake it all about to make sure that the data you're looking for appears in the right order? So let's put 5 minutes on the clock and let's make it happen.
All right, let's have a look at linked lists. So linked lists are similar to arrays. However, today we're going to be looking at how linked lists differ from arrays. Now, just a quick recap, arrays are stored in one block of memory, all right? And that memory doesn't grow, it stays as it is. Whereas a linked list is a dynamic data structure, and this is an important part of your learning. A dynamic data structure is one that will grow as needed by memory. All right, so if you don't put as many items in the data list, it's smaller. If you add to the linked list, it grows. It's as simple as that. Now, the other thing you need to bear in mind is that dynamic data structures like a linked list are unordered, and you'll see this working in a minute. And of course, they don't need to be physically stored next to each other. Each of those linked lists can be anywhere in RAM. Okay, so contiguous data locations are not needed. Now, one thing I'd like you to remember is that a linked list is made up of a data field, which holds the actual data that you want in your list, and then a pointer field. Now, that pointer field points to the next link, and we're going to see this working just now. So here's an example of a linked list. All right, we've got a linked list here. We have an index, we have the data, and we have the pointers. Now you'll notice here that you've been actually given the start index. So start index 3 means that if we were to output an order of this link, we would first look at where the start index is, that's 3, and so we can say confidently that Preston is our first part of our linked list. Okay, so Preston is the first thing that should be output in this list. So we can say we've been to 3, we've looked at Preston, and then we need to look at this thing here. Where's the pointer telling us to go next? Well, the pointer is saying go to node number 4. So we can go to node number 4 and we find Blackpool. So we can confidently say that Blackpool is the next item on our list. Okay, we put Blackpool in, and then we look at the next node that this linked list is pointing to. So this linked list is pointing to index 1. There's index 1, that's Blackburn. So we can say that the next output that we can add to our list here is Blackburn. And you get the idea. Once we've been to Blackburn, we can have a look here, and the pointer is saying now go to 0, and so we can go to 0. And that's Nelson. Just put that in there. And then finally, Nelson is pointing to node number 2, which is Manchester. So we can add Manchester to our list. So this becomes our order of output for this linked list. Okay, now we started at 3 and then we followed the order. Now we didn't go down sequentially, we just simply looked at the node and then went to the index of that particular node. There's the output order: Preston, Blackpool, Blackburn, Nelson, and then Manchester. Now once you've been to Manchester, you'll notice that here is some kind of a token or indicator to say that the linked list has finished. So that's not pointing to any index, and so we can say that the linked list has now been searched. Alright, let's have a look at this one then. Say we now want to add Burnley to this list. Again, we're starting at 3, but we want to add Burnley. So the next free available index is 5, so we can add Burnley here. Alright, we'll do that. However, we need to do a few other things. We need to update this link here. So Manchester is pointing to nothing, but in fact now we want it to point to Burnley, so we can change that to 5. Okay, just ignore that a little bit there. We're changing it to 5, so 5 is over here and Burnley is the item in it. And of course we can remove this and add some kind of a token or some kind of a symbol to say the linked list has now been completed. So once, just like earlier we looked at, we go from 2 Manchester and output now to 5. 5 is Burnley, and then we crack on. Alright, should be nice and easy. Let's look at this example. So here's what it should look like when it's finished. You can see Manchester's move link is 5. 5 takes you to Burnley, and then Burnley has some kind of a token. Okay, let's look at another example. Now let's delete Blackpool from our list. I mean, who wants to go to Blackpool, right? I'm only joking, Blackpool fans out there. So if we want to delete Blackpool, well, we can say that the index to Blackpool's 4. So Preston was pointing to 4. So originally, once you've been to Preston, you would go to node 4. So we're going to cancel that. And we're going to look at where was Blackpool pointing to. Well, Blackpool was pointing to 1. So we're going to change this to 1. Okay. And so after you've been to Preston, you go from point to 1 rather than point to 4. And point to 1 is going to Blackburn. Okay. So what would happen here is you'd go to Preston and then to 1, and then 1 goes straight over here. Okay. And then your linked list carries on. So we can now assume that 4 isn't going to be visited, and so we can just get rid of the pointer, remove the pointer, and add some kind of a line. Now, there's a couple of things you need to bear in mind is that the start index stays at 3, but this next free business, in order to keep your linked list efficient, we want to add the next free pointer to be 4. So the next time somebody adds an item to the list, it goes into 4. Otherwise, your linked list becomes huge. So here's what it might look like. All right. This is just having removed Blackpool. We've taken Blackpool out. The index is still there, but it's not being pointed at. And you can see here now, it's empty. And we can see over here that the next free index is 4. Now let's add Liverpool to our list and have it visited after Nelson. So after Nelson, it now currently points at Manchester. So first of all, the next free is Liverpool. So it's going to add Liverpool here. Okay. And we are going to say that our Liverpool after Nelson we want to visit. So after Nelson, we don't want the index 2 to be visited. So we can put index 2 here because we want it visited after Liverpool. All right. But what we do want to bear in mind is that we want after Nelson, Liverpool to be visited. So Liverpool is index 4. So we can get rid of this one and put here 4. So what will happen now is people will go to Nelson, then to index 4, which is Liverpool, and then from Liverpool to index 2, which is Manchester. And so we've just added it to our list. What does that actually mean? Have a quick look. This is what the answer might look like.